Hello YouTubers and fellow hams, new hams. Well, this is a new hams tip video, and this one comes from a suggestion by Alan Covey over on the Facebook page. And he was asking, how about a video discussion for us newly minted HF guys who have never been through an upswing of a solar cycle? That's a good question, and I think that's a good subject, and it's a relevant subject because we are right at the beginning of activity for the new solar cycle. In fact, just in the past couple of weeks, the sun has really started to kick up some activity. Sunspot numbers went way up. Solar flux went way up. We're going to start having some mass ejections and solar storms. It's going to get very active, and it's going to make HF conditions vary quite a bit up and down. It's going to be really interesting. So, Alan, this is a good question, and I think a good topic for me to cover for new hams. I think I'll start by showing you the resource that I visit every morning, and usually a couple of times throughout the day if I'm curious, where I look at what the sun is up to. And I'll show you the information that I look at and what I expect to see and happen with that information. Now, let me preface this by saying I'm no expert. I know just enough about ionospheric propagation to be dangerous. What I can draw upon is my experience. I've lived and been a ham through 2 solar cycles, and this one will be my 3rd. And I have a lot of observations that I've made over the years about what happens with the sun and how the bands behave. So this is just based on my own personal experience and what I've been able to research and understand from documents and things that I've read. So let's go look at my my number one resource for solar activity, NOAA's Space Weather Dashboard. Before we look at my resource and talk much about it, we should first just do a quick overview of what propagation actually is. Up here in the ionosphere, which is an upper layer of the atmosphere that is susceptible to being charged by solar activity, and represents the ionosphere up here, this is what is responsible for skip, or propagation. And as you can see from the graph, what we have here is signals coming from our transmitter go up, and if they're at a low enough angle, they will bounce off the ionosphere if the ionosphere is properly charged, bouncing back down to Earth. And that allows us to cover more distance via that skip than we would cover if it was just line of sight, which line of sight, our signal would go straight off into space or often bounce further down, but would never reach this station. It would go over his head. So that's what propagation is. This charged layer of the upper atmosphere acts a little bit like a mirror for radio signals and bounces them back down. Now, there are multiple layers to the ionosphere, as we can see here. There's several actually, but the ones that we're most interested in are the F, E, and D layers. The D layer, being the lowest one, is kind of important, and we'll talk about that later when we get to the space weather page. It's more active at night when the sun's not active, or when the sun's not charging things up. It tends to bounce lower frequency signals. That's why you hear AM broadcast stations and 80 meters opens up at night. That's from the D layer. During the day, when the sun's active, the D layer is much less of an influence. Signals will tend to pass right through it. The E layer, you might have heard of the term sporadic E, talking about 6 meters. VHF frequencies in around 50 megahertz for 6 meters tend to bounce off of this layer. The F layer is most important for the upper frequency bands, 20 meters, 15 meters, 10 meters, and so on. But this D layer is the lowest layer, and that's kind of important because if it is absorbing rather than bouncing signals, this happens. If this was a transmitted signal over here, you can see how it just sort of faded off in the D layer. That's called D layer absorption. And under certain solar conditions, that becomes a factor. And certain frequencies will never get up here to the upper layers to bounce. they'll be absorbed in the D layer, and propagation is hampered. So those are some important points to remember. Okay, let's go to my favorite resource. This is the National Oceanic and Atmospheric Administration's Space Weather Prediction Center page. It's a web page that gives you all kinds of information on what the sun is currently doing. And I will put this link in the description of the video below, so you can go to it and bookmark it if you're interested in going back to it. Now, the bits of information that I am most interested in on this page are the solar wind, which is indicated right here at the top, and the solar radio flux, which is 2.8 gigahertz RF coming from the sun. And that frequency does some interesting things with the ionosphere. Well, I guess it's not that frequency, but that number, this data, tracks with extreme ultraviolet, which affects the ionosphere and charges it up and causes propagation to happen. And then the other thing that I like to look at is this solar X-ray flux graph here, which shows us this flux over time, and you can see the peaks that are occurring, and what the overall level is, and whether we're hitting flare levels up here. Okay, so let's talk about this stuff. What are we looking at here? Solar wind speed over here. This is a stream of charged particles coming from the sun. It's a fairly constant stream, and during certain times with coronal mass ejections or burps of energy around sunspots, this can increase dramatically. Now we'll look at another graphic here. The solar wind pushes against the Earth's magnetic field, deforming it and then flowing around on the magnetic field lines. The Earth's magnetic field acts like a shield for us and protects us from the solar wind, which is a good thing, because the radiation and other energy in that could be devastating to life on Earth. So without our magnetic field, we wouldn't be here. And high solar wind will buffet the magnetic field and deform it and wobble it and move it around, and we call that a geomagnetic storm. And that affects radio propagation. It can affect it rather dramatically. Remember the D layer? If we go back over here, remember the D layer being lower in the ionosphere? Well, during periods of high solar wind, that D layer will begin to absorb rather than reflect signals. And if we go back here to the space weather page and we scroll down, there's all kinds of information, but down here near the bottom we see this D layer absorption prediction graph. And this graphic, it will show us if there is D layer absorption going on, and through this frequency range here in the colors, you can tell what frequencies are being attenuated or absorbed by the D layer. So this graphic, and I'll show you a picture here of this graphic during a more active time, and you can really see the colors and see where signals up to certain frequencies are being absorbed by that D layer. So that's some important information to have. If there's a lot of color on this graph, and like if you saw a big area of green over the country that you're in, you'd come down here and you could see that that color would mean that frequencies up to 24, 23 megahertz are being absorbed rather than getting through to the upper layers and bouncing back. So this D layer absorption prediction graphic is really useful on this page, and that is tied to the solar wind here. Right now this is a fairly high level. This can be down in the 300s. It can get way up into the 600s, 700s during storms, and then we'll have geomagnetic storms, and that will affect propagation because of that D layer absorption and the magnetic field being fluctuated. Okay, The other thing that I said I like to look at here is the solar radio flux. This number correlates to other components of solar radiation like extreme ultraviolet. And according to research and information on Noaa, the extreme ultraviolet emissions strongly affect the ionosphere. And this number, you want it to be high. For about 3 years now during the solar minimum, this was in the 70s or below. And we did not have a lot of propagation on higher frequency bands. The higher this number gets, the more charged up those upper layers of the ionosphere are going to get. And let's go back over to our graph. So the higher that solar flux is, the more active these upper layers are going to get, the more reflective they're going to get, and the more propagation you're going to get. There's all kinds of technical reasons for it. Like I said, I'm not an expert. I'm just sharing my observations over time and watching this data while I work with radio. So not too long ago, just a few days ago, this was around 110, which was fantastic. It was quite high. There were a lot of sunspots, and this number went up, and sure enough, there was a lot of openings. 15 meters was open almost every day, and 10 meters was opening up. In fact, here's a clip. I made a FM contact all the way across the country over in the southern states on 10 meters using only 10 watts. Out here, it's going to be in the 70s and sunny most of the time. We're pretty windy today, but temperature's coming up. I think we're going to hit about 75 today, over.
Roger, on the 75. Yeah, you dropped out on me there for a bit, and you come back up a little bit on that transmission. 10 watts. Wow, that just shows you what kind of band conditions are existing right now. It's great to see it opening up. Finally, sunspot cycle 25 beginning. Even though the sun's kind of down south in the winter, we're still getting some effects of it up here, which is pretty awesome. And 73 to you, Kevin. The name here is JB, by the way. Juliet Bravo is what I go by. And we'll say God bless and have a great Christmas coming up. KJ4JAE.
All right, KJ4JAE, you have a good day too, JB. And 73 from KB9RLW, Southwest Arizona. Kentucky. So, you know, the daytime, the sun really does make a difference. More information on this page we can look at here. This is a prediction of what they expect to be happening as far as the solar wind and the potential for magnetic storms in the coming two days. It's sometimes pretty accurate, sometimes not so much. Yesterday, it was predicting a G3 storm, which never happened. If we go and we look over here, the last few days, we should have had a big storm. This was predicting a G3 storm in through here, and well, we got a little activity right here, but we didn't really see G3. So, oftentimes this is accurate, and sometimes not, but it gives you an idea about what's coming. And this graph here shows over time geomagnetic activity, which is related to solar wind. And of course, solar X-ray flux, which is related to this number up here, this radio flux. So that's what these three graphs are for. It's looking back and sort of seeing the trend. And you also see current data. I forget how often this is updated. I think they tell you. No, they don't tell you. Nope, they don't tell you. It's updated 2 or 3 times a day, I think, or maybe a little more often. But anyway, that's historical. Scrolling down, we have satellite imagery. We can look at the ultraviolet output of the sun, and this is Earth from the Earth's point of view. And you can hit this play button, and it will show you an animation of the last few days of activity. Visible light here, this is the visible solar disk. Right now, we don't see any sunspots. Well, there's one. There's one right there, just a little bitty one. You can just see it. That's rotating out of view. The sun is rotating in this direction on this graphic. So if you see something over here like sunspots, they're rotating into our visible disk and will be aiming towards us soon. And of course, if anything is out here in this central region, then it's casting energy towards the Earth. So that can be helpful, just glancing at this to see, what's going on. Okay, this is the corona view from a satellite that has a little disk here that blocks out the sun itself. And that way you can just see the corona. And we can see energy being cast off from sunspots here, little solar flares going on. And, well, these are the regions. This is that little sunspot we saw over here. This is something that's around the back side of the disk yet that hasn't rotated in our direction. So there's something active back there that might give us some activity coming up. So that's how you can use these to sort of see, what the sun's actually looking like and what's coming. And we scroll down. This, again, prediction graph, this is kind of based on some of that data that we saw up above. And sometimes it's accurate, sometimes not so much. You can just see right here the remains of that predicted G3 storm that we didn't have. We didn't even get up to G1. So they were expecting it to be much stronger than it was. So again, sometimes it's accurate. It gives you an idea of the trends and what's happening. Let's go down further. Aurora Forecast over here is neat. This green area shows you where auroral activity is going on, and so you can see how far south the auroras are. When you have big geomagnetic storms, a lot of solar wind, you'll see increased auroral activity. And so the stronger that solar wind gets, you'll see this move further down, maybe even getting into the northern United States if we have a severe storm of G3 or G4 levels. These graphs here are again more trends from the geosatellites. Mirrors some of the information in that upper graph, so I don't pay too much attention to that. And then here, of course, is that D region absorption graphic that I really like to look at just to see, if we're in a solar storm and there's color, you can tell, I'm not going to be able to do too much below that frequency because it's going to get absorbed by the D layer and you'll be stuck with ground propagation. And then finally down here at the bottom, the solar cycle graphs. These are showing over years the activity. And you can see here sunspot numbers. This was the dead period that we're just coming out of. And this was the peak of activity just a few days ago where solar flux got up over 110, and we really saw a bunch of openings on 10 meters and 15 meters. Further down here, the solar radio flux again. And this is going to pretty much mirror the sunspot numbers. You can see a correlation between these peaks here and here. See the peaks? So you could pick and choose which of these graphs you want to look at. They're pretty much going to give you the same kind of information as far as what's going on. But as you can see, we are right at the beginning of the upward trend of the new cycle. It's just starting to happen. So you'll want to watch this. As these flux numbers get up over 100, maybe even up over 125, I mean, they can get way up there. Look at this, almost 175 during the last peak. That was an interesting time. You could get on 10 meters just about any time of the day or night and work DX once the numbers got that high. So very useful information on this page. And as I said, I will put a link in the description down below. So that's basically how you can kind of keep an eye on what's going on and what you can expect to happen. Now, the other part of Alan's question was, should I be worried about my antennas, my radios, with solar storms? And the answer to that is, I don't know. It's hard to say. You would have to have a very severe solar storm. If we get a massive ejection, a massive storm, and that G level is up to G5, that amount of activity in the magnetic field, the magnetic field will be fluctuating, being pushed around by the solar wind, it'll be fluctuating. And a moving magnetic field across a wire induces current. If that solar storm gets up to those levels, yeah, it could induce currents on your antennas, high voltages and currents, and possibly damage your radios. So you should be worried about it if we get up to those storm levels. There is an event historically, a massive, massive solar flare. I think it's called the Carrington event. It was a very, very substantial solar storm. And what was interesting about that one was we had the telegraph at the time. There were telegraph lines across the countries and across, and being used to communicate. And there was so much current being induced on those telegraph wires that the telegraph operators actually disconnected their batteries from the wires. There was enough current on the wire that they could still close their key and close the contactors at the other end of the wire just with the current that was on there. And some of them got shocks too. So yeah, a massive solar storm can induce high currents and voltages onto the wires of your antenna and possibly damage your radio. So you should worry about it when when you see that we're going to have a solar storm that's G4, G5, or an X-class solar flare. If you're not going to be using your radio, maybe it is a good idea to unhook your antennas or ground them, just to be safe. So there you go. If you're a new ham, I hope that you found some of that information useful, and I say welcome to the hobby, and you're really going to enjoy this solar cycle, as I'm sure most of the rest of us are as well. It's really starting to kick off, and we've got 4, 5, 6 years of good solar activity coming, so buckle up, get your radios out, get your antennas shined up, and hit the air. We'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.